In this lesson, we are talking about sketching functions given a scenario. So in part 1, it says that when you draw a graph without actual data, you are making a sketch. So here we are asked to draw a sketch of this scenario. An athlete measures her pulse rate during a 50-minute workout. The workout includes a 10-minute warm-up period and a 5-minute cool-down period. Sketch and label a graph showing her pulse rate during her workout. So when she is warming up, that means her pulse rate is increasing. And when she's cooling down, that means her pulse rate is decreasing. Okay, so now let's go to the graph, and first of all we need to label our x and y axis. So our x-axis is going to be time, and our y-axis is going to be her pulse rate, or heart rate. Since we don't have her actual pulse rate or her heart rate given, that is why this is just going to be a sketch. We do know that her warm-up period is 10 minutes. So on my time, I'm going to go from 0 up to 50 minutes since her workout was 50 minutes long. So 10, 20, 30, 40, 50. And we know that her heart rate increases during the warm-up. Now, we certainly do not want to start at the origin. The origin would mean that when she starts her workout, her heart rate is 0. And we know that if her heart rate is 0, she would not be alive. So we don't want to start there. So we need to start somewhere up on the y-axis. Since we don't have numbers, it doesn't really matter where, but we are just going to sketch. We definitely don't want to start at 0 though. So let's start maybe right up here on the y-axis, and then for the first 10 minutes her heart rate is going to increase, and then during her workout she probably will maintain a steady heart rate, and the last 5 minutes of her workout, so right about here is 45, that means her heart rate is going to decrease until 50 minutes. Now, typically when we work out, we don't cool down until our heart rate is below our resting rate. So that's a good sketch for the graph. Let's move on to the next example. Part 1, got it. You have an empty rain bucket in your yard to collect rainwater. Rain falls for 6 hours and then stops. After 5 hours, the rain begins again and lasts for 1 more hour. Sketch a graph to represent the volume of the water in your bucket during this time. So we need to label our axes. So time is our x-axis, and it says here volume of water, so that's going to be my y-axis. Now we have to consider how long we are talking about in time in hours. So if we read carefully, it says it rains for 6 hours, it stops, and then after 5 more hours, so that's a total of 11, the rain begins again and lasts for 1 more hour. So we know that we have to cover at least 12 hours on my graph. Since there are only 10 spaces on my graph, I am going to count by 2's on my scale. So my scale is going to be 2 hours. 2, 4, 6, 8, 10, 12. And my volume of water, I don't know how much I'm collecting, but I do know that the bucket fills up, so the volume of water increases when it rains. So it says that it rains for the first 6 hours, and I would say that my bucket will start with nothing in it. So I'm going to start at 0, 0, and for the first 6 hours, it's going to fill up my bucket, and then the rain stops for 5 hours. So that means that my bucket stays at the same level for 5 hours. So I'm going right in between the 10 and the 12 there. And then for another hour, it rains again, so it's going to increase some more. So that is a decent sketch of the scenario. Alright, turn your papers over to the back side. Now we have graphs shown, and we have to choose which scenario matches which graph. So scenario A says that you leave home and ride your bike to the library, where you stay for a while doing research for your science report. Then you ride to your friend's house. B says you ride your bike home from soccer practice. On the way, you stop at your friend's house for a while, and then go straight home. So you have to decide which graph represents each scenario. If you take a look at what your y-axis is, it's distance from home, and your x-axis is time. So, which one starts with the distance away, and which one starts with you being 0 distance from home? So A says you leave home, so that means that you start at home, which means that scenario A is the bottom one. You start at home, you go to the library, so your distance away from home is increasing as you go to the library. You stay at the library, so that means it's a constant. And then you go over to your friend's house, who must live further away from your house than the library. For part B, or scenario B, that would have to mean that this is B. You ride your bike home from soccer practice, but on the way you stop at your friend's house. So here's soccer practice, you're riding your bike home, you stop at your friend's house, and then after a while, you go home. So your distance is 0 when you get home. So let's take a look at this part here. As you leave home, your distance from home increases. While you're at the library, your distance from home is constant. And when you ride to your friend's house, your distance from home increases again. When you ride home from practice, your distance from home decreases. When you're stopped at your friend's house, your distance from home is constant. And when you head home from your friend's house, your distance from home decreases again. Okay, now part 2 is missing an important phrase in the question. So we need to definitely add something here. It says each graph describes the height of a candle, and then we have to add in that is burning. So add that in, otherwise there is no correct answer. So we're talking about a burning candle over a certain period of time. And it asks, which graph is not a reasonable description for the situation? So because I added that it is a burning candle, there's only one that doesn't make sense. In scenario 1 here, this makes sense because we're not burning the candle, then we light it, so its height decreases, and then we blow out the candle. It stays the same height while it's not being burnt. Then we light it again, it burns. We blow it out, it stays constant. We light it again, and it burns. So that scenario makes sense. Scenario 2, we light the candle, it burns all the way down so that it goes away. So that makes sense. Scenario 3, the height does not change, and since I added in that it's burning, this is the one that doesn't make sense. So 3 does not make sense. Now I would like for you to answer the following questions on your Google form. So the Google form can be found at bit.ly/sketching function graphs. And it's just numbers 1, 2, and 3 here. You have to match the graph with the scenario.